Okay, welcome to the session. So basically, this session is about whether the DevOps can be used for embedded development or not. So for the embedded guys, there might be a question yeah, we haven't heard of DevOps and we have seen or from where the software counterparts using DevOps. So many of us would be interested if at all DevOps could be used for embedded development or not. So before going to that, let us see what are all the different phases in the product development. So when a product is developed, there are different phases in this development where you start the project by gathering requirements, and then you develop the specifications, do a feasibility study, and then you model the things. So all these comes under the design, and then this design would be used for these requirements and all would be used to develop whether you develop a firmware or hardware or the software, and then you test these things, you integrate them, and then you deliver them. So what is the theme of basically this product development? So in the previous slide we have seen the different phases. So the major theme is that there are designs which are getting complex day by day, and these designs need to be developed in as quick time as possible, so the development times should get faster, and then the organizations need to go to the market to sell their products. So this is the major theme, and definitely following all these would reduce the timelines and help them save costs. So one has to understand that these themes are the major thing which you need to follow while, or which are being followed these days by the companies while coming up with designs. So let us see how different methodologies are used in the product development these days. To achieve those theme or to achieve your product, there are different methodologies that are followed. One is waterfall, agile, or the DevOps. So we don't want to go into further topics, we just want to restrict these to these three methodologies. Waterfall is the basic methodology we follow, where you gather the requirements, you design, you develop, test, deliver. So there is a sequence that is followed here. You can see here there is a sequence. So everyone wants to follow the sequence, and the test engineer would only get to develop or test something only after everything has been developed. So there is a sequential approach that is being followed in the traditional waterfall methodology, where all our design engineers or generic embedded systems follow. Now the second methodology is the agile, where speed is the primary criteria, and there is a well-defined framework that is followed by developers worldwide, where they use the agile framework for their projects. Now DevOps is another methodology where it can be said as an extension of agile at a very high level, where the delivery and the operations team, the development and the operations team are brought together to come up with a new strategy where you want to reduce the development cycle. So we'll talk about that in the later videos. Now let us talk about the difference between agile and the waterfall. So in the waterfall methodology, one of the major criteria is that the features or the requirements are developed at a very high level, where some expert sits and defines the features and requirements, and then those will be drilled down to the team further below, where the team uses it to come up with the design. So now for that, time, cost, the amount of work done, the quality, all are dependent on features and requirements, rather than a criteria has been defined for time and cost. So features are very important aspect of waterfall, whereas when you come to agile methodology, the time, the cost, and the quality are the primary criteria around which you define your project. So now here one of the major point is that the speed of execution and the continuous feedback are the two important things in agile. So you can see clearly the difference between them. Now one thought, so when we are talking about agile and waterfall previously, let us assume some scenarios where let us assume I am developing a product, or I am writing a firmware or a software where I have to test and then deliver, it goes to the field, or then to the production. All these cases come back, and then the developer sits and then does the thing, which is similar to the waterfall methodology. Rather than that, if when you are developing the firmware or the software itself, if your release reaches the quality of production batch, then you can think how much time you can save, rather than waiting for someone to give a opinion at a later point of time. So you can clearly see the advantage there. For that, one of the important point is that you must have a continuous feedback between testers, developers, the integrators, and then the deployment team, and then the operations team. So there must be a continuous feedback between all these guys. Now that is where DevOps comes into the picture. So the thought where when you develop something of a best quality, which can be directly released to the market, and where you have a continuous feedback between the different teams, the cross-functional teams, that is where the DevOps comes into the picture. So DevOps merge the development and the operations. So you can see development is the development team, and the operations are like where they work on the end product. So if they come together, you know the advantages. They can give a continuous feedback, develop a big software project. There will be number of people who works on it. Example, if a team size is 10, so the people might integrate it on a daily basis or a weekly basis, depending on the project requirements, and then you continuously deploy it, take the feedback, and again you develop based on the comments you receive. So it's like a continuous integration and continuous development that is happening, where the behavioral driven monitoring is being taken into consideration for these things. So you know what is working and what is not working well during your development phase itself, and you get a chance to work on it. Now to achieve this, one of the important point is you must have a good collaboration and good cross-functional communication. So if you see these two terms, collaboration and cross-functional communication, you can clearly say if you want to communicate between these many guys, you can assume the tools that can be used in the background to bring all these guys together. So here the automation tools play a major role, and then the DevOps definitely speeds up the entire process, as we have been saying. And the major advantage is that you increase the visibility. Everyone knows what is happening, and they can act fast, and definitely it ensures a good governance. So you can see the so the feel of DevOps, where you get a feel of all the things coming together, working together collaboratively, and getting to know the things, taking feedback from different teams, working on the issues, and closing the things as soon as possible, and as we said, coming up with a production quality software during the development itself. Now, to just put it in a flow manner, the development team in DevOps releases in a very frequently, and then this will be used by the deployment team to test the things, and there is a continuous feedback on the working of that, and they give the feedback to the development team. So there is a continuous chain that is running, which runs forever till the project gets completed. So these things are very familiar in the software development scenarios, where they call software as a service, and it works very well in that environment. Now, this is what a DevOps, so at a first look of it, if you are not aware of DevOps at all, you see a infinite symbol here. Infinite means forever, right, in mathematical terminology. So that means as long as the project runs, you plan the things, you code, you build the things, you test them, and then release to the operations team. They deploy, they operate it, and they monitor the functionality, and then come back to the development team again, and then the development team plans it, codes, builds. So there is a continuous cycle, infinite cycle, that runs till the project closure here. You can see a simple diagram here which explains the DevOps. Now, why DevOps is very relevant to the software? So as I was talking in the initial slides, I was saying embedded guys should be surprised hearing about DevOps. DevOps is very relevant to the software because software guys can virtualize the things so that they can abstract the end infrastructure. What we mean by this is that suppose if a software engineer is working on a project, let us assume he is developing a web page. So if this guy what this guy can do is can test the web page here itself. He can see a end user in himself, simulate the things, sit with the test team, and come up with the virtualization of the end user, and he can test the things so that by the time this application goes to the web page, goes to the end user, this is already tested because the developer himself acted as a end user, and he knew what are all the disadvantages with this. So the major advantage when we use the DevOps in software is that the cycle becomes easy for him because he clearly knows the interdependencies, he knows whom to approach, how to test it, what is the end user going to do with this page, what are the different cases that are going to come up. So he's very much clear on what need to be done. So that's why you can see that for software guys, DevOps is very much relevant. Now, combining all these things, what are the different topics in the DevOps methodology? As we clearly said, DevOps is going to bring the development and the operations together. So as a part of this, we said there should be some deployment, and then there will be a continuous feedback. The cross-functional teams work together, and they collaborate. There will be a continuous development happening, continuous integration, and definitely in the DevOps also the agile practices, whatever are there, would be followed for the development. So the DevOps is we can say is an addition to the agile which is already used. So one of the major point one has to remember here is the automation related thing, which is very important. So DevOps mainly works on automation. So it needs automation, because whether it be tools or during the testing side or any other cross-functional communication or any communication between the development and the operations to happen, there should be different tools that need to be available, and that's what this methodology stresses upon. Now, coming to the embedded system, why we why only software can use DevOps, why cannot embedded domain? So in the embedded domain, we know that there can be different scenarios where you can do a new product design from the scratch, or there could be a redesign related things. Whatever may be the things here, the specifications are defined at the beginning of the project. So now the teams underneath work based on those specifications, and the major point here is that there is a dependency on the hardware. So when we were talking about the DevOps suitability to software, we were saying that because of the virtualization, you can clearly replicate the scenarios what the end user is going to see, and then you can test the same in sitting at your place itself while developing the software. But for the hardware, it is very difficult, because you cannot virtualize the hardware, because hardware need to be developed from the scratch based on the requirement. For example, if you need to read a temperature sensor using a controller board, definitely you need to have you need to develop a software based on the specifications. So the major dependency or the drawback that we can say while taking DevOps into the software is the hardware. Now, the software and the firmware are hardware driven. So unless you have the hardware in hand, the software and the firmware cannot be developed, or at least you should have a basic knowledge of the basic ingredients of what are going into the software and the firmware. Now one can comment saying, yeah, we use evolution board or previous boards to develop the firmware, but that's very minimal functionality that you can test over here, where you can only simulate some of the things, but the end hardware is what the actual thing that you need to work on. So you can see there is a dependency, there is a sequence required here, and from the software front, as similar to the software development, you cannot have features changed. Features are defined at the beginning of the embedded product itself, and you develop the design and develop the things based on those features. So definitely in embedded, if you see, there is very little chance that you can use DevOps. So one more major disadvantage is that whenever the embedded designer or a company are developing the products, the embedded products, they develop and then they give it to an end customer, and it will be used in a field where someone else uses it. So it takes a lot of time for the feedback to come back, unless unlike the software development scenario where the exact software will be used in the field also by the end user. Whereas in embedded system, the small part of the system you develop will be part of a bigger system at the customer level or the field level, where you may not be able to replicate in most of the scenarios. So you can see here there are many disadvantages or the sequential things that need to happen with respect to the embedded domain, whereas the software has that capability or the flexibility to use the DevOps in their development. Now, can we use to some parts of the embedded development? Yes, we can say the firmware development definitely can use DevOps, because by the time the firmware development starts, or some of the firmware development, if at all, if example, if firmware development is using a enhancement of a particular functionality, which we call it a redesign of the firmware. So in those cases, already a hardware is defined, you know the end system. So what we can do is, you already have a system in place. There is even though there is a dependency on the hardware is already developed. So the firmware guys can follow some of the can follow DevOps to deploy their DevOps methodologies in their development. And also the verification and validation team or the test integration team can definitely use this, because for the verification and validation team, they just test a end system, whereas there is no development involved in it. They just give a feedback to the developer, and then again it comes back to the tester. They test it on the actual system which is going to the end user. So they can use DevOps. And finally, the IoT development. So IoT development, we can say it is comprising of different teams. It could be hardware, it could be firmware, it could be software. So in the software, cloud or any application, small scripts from the test verification validation teams. So there are IoT side, we can say it is a mix of the things. So IoT development can definitely use DevOps when they are developing the software level applications, whereas the hardware need to be defined and available for that specific team to follow this, because unless the hardware is available, they cannot follow this. So IoT development can definitely follow DevOps when they are doing a embedded development. So to put it in a simple way, the embedded development, if you are doing a new product development where you have a clear requirement and then you have to deliver a system to your customer, and this product need to be used in end system, you cannot use the DevOps methodology in most of the cases, especially if there is a hardware dependency. Whereas if there is a redesign kind of activity which is happening where the firmware need to be developed independently, then definitely you can use DevOps in those scenarios. If there is a test team which is working on a product that is developed, and where they receive the continuous feedback from the field or from the developer, and they take the feedback, again test. So these scenarios again can also come under DevOps. So we can say it is dependent on the case to case where we can use this. It's not that we cannot completely use it, but there are restrictions, and one of the major restriction is from the hardware side.